Okay, thanks for sharing those angles in the chat, everybody. Um, so you may have found, some of you, that you're like, hey, some of these are ending up negative, and I'm not sure why. And that's okay. All will be made clear. So Emmy said, is it because you're on the bottom half of the circle? You're definitely on the right track with that. Yeah, so my answer would be it depends on what sign ratio we're looking at, but yes, you're definitely on the right track. It being on the bottom half, you'll notice that all of these ones are on the top half of the circle. And so that might be why that is. And I'll show you why it might matter what part of the circle you're in. Great, so we got a whole bunch of angles, and we find that as long as we're moving around the circle and either ending up in the exact same position by adding 360 degrees, or in the case of the sine ratio, if we're going on the other side of the circle and we're creating a triangle that looks the same and has the same interior angles, as long as we're on that top half of the circle, then it's still coming out the same and coming out positive. If you go to the bottom half of the circle, in that quadrant we call quadrant 3, then you'll notice all of a sudden you're getting negative answers, the same value, but some of them will be negative. And I'll explain why that is next. That's actually what we're going to look at right now. Just a reminder, everybody, I'm recording. We had one or two people whose Teams app crashed, so I'm just recording the screen right now. So if you decide to turn on your mic, that's fine, but your audio will be recorded along with the smartboard screen, okay? So just fair warning there. Okay, so let's have a look at this one. Now I've got a new angle. This one I've gone past 180 degrees, right? And a little bit more. I've actually added an extra 30 degrees because I'm focusing kind of on 30 degrees here. So this is 180 plus the triangle gets us to another 30. That's 210 degrees is this one. Now if you put this one in, you go sine of 210. You'll find that you get 0.5, but it's negative. And it's like, oh, okay, that's kind of weird. It creates the same triangle, but I got a negative answer. And similarly here, we got this one. If you go all the way around, but you're short of getting to 360 by a little bit, you're 30 degrees short. That's 330 degrees. We've created that triangle again. But sine of 330, for some reason, gives you a negative one. Negative answer. Weird. Now, is it just because it's in the bottom half of the circle? So yes, but it's a little more complicated than that, because if you try the same thing with a cosine ratio, it doesn't work out quite the same. The same ones aren't positive and negative. And if you try it with tan, again, same thing. The same ones aren't positive and negative. So there is a pattern, but it's not, you can't really tell by the way we've done it here. So why are these ones negative? It is because they're in the bottom half of the circle. But that's only for sine. So let's see why this is actually happening. I think what you're going to see on the next page will help. Okay? So what I'm going to ask you to do is I'm going to ask you to use your calculator, and I'm going to ask you to fill in the sine of 30, the cos of 30, and the tan of 30 for this 30-degree angle. And then I'm going to ask you to do the same thing for 150, 210, and 330. I'd like you to do that right now. Let's take 2 minutes on your paper. I'd like you to write down the sine, cosine, tan, sine, cosine, tan, sine, cosine, tan, sine, cosine, tan for those 4 different angles and see what kind of signs you get. And we're going to do a little bit of looking for patterns. So please take care of that right now. when you're writing your ratios, everybody, you can just write them to 4 decimal places and round them off if they're a continuing decimal. So rounding off to 4 decimal places will be perfect. When you've completed this, I'm going to ask you to highlight or circle the positive answers. So when you're done this, I'd like you to highlight or circle the positive answers. And when you're finished, can you please just type done into the chat so I'll know that you are good to go. I'm going to start writing some of these in, but I'm a little bit behind you. Okay, I'm seeing most people are finished up, so I'm going to finish up my highlighting here. I'm highlighting just the positive answers. So here's my pattern. I noticed that in this first area, we call this area quadrant 1. in graphing, when you're doing graphing, that's what that area is called, where the x and the y's are both positive, right? We call that quadrant 1. So in quadrant 1, sine, cos, and tan are all positive. In quadrant 2, if we end up over here, I notice that only sine ratios are positive. Cos and tan are negative. In quadrant 3, we discovered earlier that sine would be negative, but it turns out cos is negative too. In fact, tan is the only one that's positive here. And in quadrant 4, again below our line, we knew sine would be negative because we'd already figured that out. But it turns out cosine is actually positive there. So I want to give you a handy-dandy little reminder tool that's going to make this really easy to remember which one is which and where. So in a moment I'm going to flip the screen. This is something that's in your book, but the one I've cropped out is not from your book, because the one I've cropped out I think is a little more useful. I think it's a little better. And so it's one that I would recommend that you have on your your cheat sheet. So really your quick access, most important information sheet. Okay. So what I'm going to do now is I'm going to flip to my next page, and this is our kind of quick little reminder. This is called the CAST rule. Now it's called the CAST rule, C-A-S-T. But that's kind of weird, right? Like normally we would start in here in quadrant 1. And I'm actually going to label the quadrants in here as well. Let's do it in green. So here's quadrant 1. We call this quadrant 2. Going around clockwise, we call this quadrant 3. And finally, we call this quadrant 4. When we're doing graphing, you've probably seen this before, but if not, now you know how we number those when we're talking about them. Now, the weird thing is, like, why don't we call this, just to remember, why don't we go in order of quadrants? Why don't we call this ASTC to remember? ASTK. But ASTK is hard to remember. So because it's hard to remember, math nerds have decided to call this the CAST rule, C-A-S-T, and start in quadrant 4 and then go around. And that's just because it's easier to remember the letters. So this is called the CAST rule. And it tells you where different angles are positive. So in quadrant 1, sine, cos, and tan ratios are all positive. In quadrant 2, only sine is positive, and we found that out when we tested angles there. In quadrant 3, we find that only tangent ratios are positive, and in quadrant 4, we find out that only cosine ratios are positive. So I want to give you a minute to record that, because this is going to be a handy thing that we're going to refer to over and over again. So I've written in the chat, please record CAST rule. When you've got that done and have written that down, I'm going to ask you to just type out a done into the chat. In today's agenda, I'm also going to link to some videos that if you want to or review this stuff a bit more beyond what we've done in class that will help you with that. So this is something that you'll see again in 12th grade math courses. This comes up, the good old CAST rule. It's telling us which is positive and negative where. Okay, we're going to go 40 more seconds and then we're moving on. If you get stuck and I've moved on and you need to finish writing this down, just type in any web browser CAST rule, hit enter, and you're going to find this image or very similar images to this. That's where I got this from. I just looked online and found the one that I thought was kind of fit our lesson the best. Okay, I'm going to move on, and I want to throw some terms at you. For the 11U class, these are in your textbook. So I've just cropped them out of there, but I want to kind of highlight a little bit of the language. I want to hang some language on here. So here we go. Let's talk about some of the language here. You're going to see this term called standard position, and standard position just means we're starting here on what we traditionally call the x-axis right here. So we're starting from there, and we're going to travel this direction for when we're making our angles. So that's just traditionally called your standard position in the Cartesian plane. So we know that we're all talking about the same thing. Okay, so angles are measured from this thing called the initial arm. That's right here. That's our initial arm. And they go counterclockwise, and they end up here at this thing called the terminal arm. And that's when we make our triangle, right? That makes our triangle. So we start at the initial arm on the x-axis, and then we go to our terminal arm, and we call that our standard position. Okay, so initial arm, terminal arm, standard position. Here's a little more. Of course, we've seen the quadrant stuff we've already talked about. So quadrant 1, quadrant 2, quadrant 3, and quadrant 4. The initial arm was the one that was right here. The terminal arm is that one right there. The principal angle is this angle here. And we usually use the angle theta for that one. Okay, so that's the angle in between the initial arm and the terminal arm going counterclockwise. We call that our principal angle. And our related acute angle is this one right here. And we use a beta for that, usually. That's the traditional way it's labeled. So you're going to see that. If you're doing questions related to this, you're going to see them described as theta and beta. So principal angle and related acute angle. And of course, negative angles go this direction. They go clockwise. So that's an example of negative 210 degrees. We're turning opposite the traditional way. So we usually label that as the negative direction, negative degrees. And you can't have negative degrees when we're drawing triangles like normally, when we're just like, hey, let's use SOHCAHTOA and solve for this triangle. But you can have negative degrees when you're dealing with all these more advanced applications of trigonometry. It just means you're spinning the opposite way. So now the question was, why is it like this? And I want to go through like our cast rule, right? Why is this true? Why are all of them positive in this quadrant? So we use an A. Oh, I didn't mention this, why we have CAST. Sorry, I should have done that. I'll do that now. Our good old cast rule. Oh, I got an announcement coming. I'm going to pause for a minute.
Would teachers please dismiss students riding buses north 9 and north 10? That's students riding buses north 9 and north 10.
Okay, so why is this called the cast rule? Well, this is called the cast rule because in this quadrant, we use an A because all of the different signs are positive. In this quadrant, S is for sign, only the sign ratios are positive. In this quadrant, we use a T because only the tan ratios are positive. And in this quadrant, we use a cos because or a C because only the cos ratios are positive. So our cast rule is just cos, all, sine, and tangent. Those letters tell us which ones are positive. So that's why it's called the cast rule, because the letters correspond with which trig ratios are positive in that quadrant. Okay, so I want to jump to here. And what I'm going to do here is I'm going to look at all four quadrants. I'll look first at quadrant 1, quadrant 2, quadrant 3, and quadrant 4. And this is going to show us why the different ratios are positive. Why in quadrant 1 are all the ratios positive? Well, here's why. In quadrant 1, our principal angle looks like that. It's somewhere between 0 and 90 degrees. I'm not sure. To me, it looks like about 45, something in that ballpark. And I've labeled my sides of my triangle. I've labeled this bottom one X because it's on the X-axis. I've labeled this one that goes up, my opposite side. I've labeled it Y because it goes in the direction of the Y-axis. And I've labeled the hypotenuse on that triangle R because if I were to spin around, that would be the radius of the circle. Just like with our Singapore swing Ferris wheel. It would be the radius of the circle. So I'll label it as R. So I'm going to do my ratios now. Sine, I remember, is opposite over hypotenuse. So if that's my angle, my opposite is right here. And my hypotenuse is right here. So sine theta is going to be opposite, that's Y, over hypotenuse is R. Cosine is adjacent over hypotenuse. My adjacent side is the X. So I'm going to say cosine is X over R. And tangent is opposite over adjacent. It's going to be Y over X.
Floor even number classrooms, please. That's second floor even number classrooms.
You can see that the sides for all those are positive because we're in the positive quadrant, right? We've got positive X and positive Y. So all of those are going to be positive. So any ratio we end up with in that quadrant is going to be positive. What if we keep turning, though? What if we keep turning and we turn to here? Well, I notice now that my X value right along here is on the negative X-axis, right? We're used to graphing and our negative X values go on this side of the origin. My Y values, though, are still in the positive Y side. They're not down here, they're up here. So they're in the positive Y side. So my Y values in my little triangle that I've made are going to be positive, but my X values, if I'm putting them over here, are going to be negative. So if I do, again, my sine theta, sine is opposite over hypotenuse. So my opposite side is my Y, and my hypotenuse is R. So that's positive. For cosine, it's adjacent over hypotenuse. Well, my adjacent side is negative X because we've moved to the left of the origin. That's where X values are negative. So this is actually going to give us a negative value when we do our cosine ratio because the X side of the triangle is negative. It's in the negative spot for where X values go. And tan is opposite over adjacent, so Y over negative X. So that's also negative. So only sine ratios are positive because sine ratios are using the Y, which is positive in this part of the graph, and our hypotenuse, which is going to be positive. Let's go to our third one.
Would teachers please dismiss first floor even number classrooms? First floor even number classrooms.
I notice here that my y value is below the y-axis. So that means I'm going to have negative y values. My x is to the left of the origin here, so my x values are going to be negative. So both of those are going to be negative if I plug in those values when we're dealing with the graph. So let's see what we end up with when we write our ratios. Sine is opposite, that's negative y, over hypotenuse, that's r. So that's going to be negative value. Cosine is adjacent, that's negative x over hypotenuse, so that's going to be also a negative value. Tangent is opposite over adjacent. Oh, a negative divided by a negative, that cancels out to be a positive. So because the two sides are both negative, they'll cancel out to be a positive, and I end up with a positive tan ratio. So whenever I take the tangent of an angle, like this, that ends up in the third quadrant, it's going to be greater than 180 degrees, but less than 270, it's going to be positive. And you can test this on your calculator. You can grab your calculator, you can plug in sine of, I don't know, some angle greater than 180 and less than 270. Let's say sine of 210, and you'll find that you get a negative answer. Cos of 210, you'll find you get a negative answer. Tan of 210, you get a positive answer, because the two sides of the triangle are both negative, which is going to cancel each other out. So we end up with a positive tan ratio. So tangent numbers are always going to be positive when they're in between 180 and 270. Let's keep going around our circle.
Would teachers please dismiss second floor odd number classrooms? Second floor odd number classrooms.
So this is going to be any angle that's greater than 270 and less than 360. You can plug that into your calculator and see what you get, but let's have a look at our ratios. Sine is opposite over hypotenuse. Cos is adjacent over hypotenuse. And tan is opposite over adjacent. So you'll find that cosine is the only one that's positive. So any angle between 270 and 360, if you plug that into your calculator, if you're doing the cosine ratio, it's going to be positive. If you're doing sine or tan, it's going to be negative. Any angle bigger than 270 and less than 360. You can keep going around and around and around, but we're going to stick between 0 and 360 because that's enough. Okay, so this is heavy stuff. I don't pretend like this is easy, and we haven't practiced this with problems yet. I do want to do a bit of that tomorrow and make it a bit more tangible. And I warned you, but I'll say it again, this stuff is hard to wrap your brain around. So if you're like, Mr. Roy rambled on and on for like an hour, and now I'm just more confused than when I started, that's okay. I think we need to actually do some practice with it and juggle with it a bit before you will feel comfortable with it. So if you're in that spot, that's okay. I want to say thanks for hanging in there with a topic that is difficult. You'll feel better about it once you've had a bit more of a chance to play with it, though. I want to do a little change of the homework. I think in the course of doing this lesson, I've decided that I want to change things up a little bit. I initially, for the homework, had it look like this. But I think I want to scrap all of that, and instead I just want to, because some of you are still working on your assignment, I think I just want to assign a video for you to watch. So, on our EDSB page, item number 5 was, hey, watch this video. That helps to describe why. It's pretty fun and interesting, and it describes, for a nerdy math video, and it describes why trigonometry and spinning around a circle, why those two things are related to one another, and why trigonometry could really be called circle functions.
The teachers please dismiss first floor odd number classrooms, please. First
So I'm going to go on to EDSB right now, and I'm going to change that. Your homework for tonight, besides finishing up and submitting that assignment, is only going to be watch that video. So it's about 12 or 15 minutes. You could do it right now and get it out of the way. So the first thing I'm going to do immediately right now is I'm going to go to EDSB, and I'm going to change that and make that your homework for tonight. Just watch that video, okay? And finish up your assignment and get that handed in. That'll take me about 2 minutes. Once I'm done that, if you are good to go, you can go and watch that video and use that to finish off the rest of class. The timing will work out perfectly. If you have assignment questions, you can stick around and you can take the last little bit of time we've got in class now to ask me those assignment questions. Okay? So either watching the video or sticking around to ask me assignment questions. Given that I'm giving you something to go do, Emma, go ahead. I see you've got a question. Okay, so I'll be happy to take that in just a moment. Thanks. Good stuff. Leave your hand up for now on Teams. So I'll ask you, because I'm sending you off in 2 different directions, to stick around and ask assignment questions or to go watch that video as your homework. I'll ask you now to unmute and just say, wave and say goodbye to everybody. Bye, folks. Okay, so thanks for hanging in there in what is, I know, a bit of a tough lesson. I'm headed to EDSB right now to change that homework around, and I'll be ready to answer your assignment questions. We've got Emma and Kesa, so you two are first up. Give me 2 minutes, and we'll jump in there.